Morning, everyone. Welcome to this session number 506. Today we have this problem is the LRU cache is pattern design, I think, concerned to the cache. It's very interesting this, but well. Um, okay, design a data structure that follows the constraints of least recently used. Implement the least recently used cache class. Okay, the first method that have one parameter capacity. Initialize the LRU cache with positive size capacity. Okay, the function get with the parameter key return the value of the key if the key exists. Otherwise, return less one. Okay. Now, the put is the key and the value. Update the value of the key exceeds. Otherwise, the key value pay the number of key exceed from the operation. The value of the series of bits. This is recently used key. Okay. The function get and put must be each run in constant time. Complexity. Mm, okay. The first point is that the least recently used. The idea is that every time that, for example, if you have one list with the next elements, you imagine that 1, 2, 3, 4, 5, and now I use, for example, the 5. When I am saying use, basically is, for example, a get or update or something like that. Now the 5 is a very horrible example. The 2, for example, I make the query, what is the value of 2? Okay, in this case, return the value, whatever. And now these 2 increase the number of every value mm, will change this by letters. Okay, and every item, in this case, have an integer that represent the between more highest is the value means that is the most recently. For example, if at the beginning all have, for example, 0 0 0 0 0, and the first query is, okay, give me the value of the key C. In this case, return the value of C, and now this increasing 1. For example, 0 plus 1 is 1, and now this is the lastest recently use, and continue and continue and continue. In essential, this is the algorithm, with concern to the cache. Now, here the point is that the trick here is that the get and put must each run in constant average time. Mm. Mm-mm-mm. Okay, and I will copy this example and constant time. Okay, the first point is that we have capacity defined. Yeah, in this case, for example, if the capacity is a 2, okay, is that I need one data structure. I'm not sure in this moment which, but one structure with this size, okay? This case is 2. Done, and is done and done. Now the next that is put. In this case, I think that I can define this side as the most recently. Mm, yeah, this. Yeah, in this case, put, uh, and this is the key, and this is the value. Okay, imagine that is 1 and 1. The value, I need 3 elements. One that represent this is the key, this is the value, and this is the weight, yeah, in this algorithm. In this case, right now, this have 0, 0, 0. And this, if I sort by this element, this is the first element that should be appear in the front of the list. Yeah. Now, okay, this is done. Now the next, okay, done, done, and done. Now the next that is this is 2 and 2. Okay, now I create, for example, 2, 2, 2, and no, this is 1. Yeah. Now this should be appear here. In this point, I'm not sure if this should be appear in the front, if have the same value. I think that, yeah. One, 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 two, two. Okay. Now this is the most recently. Now the next that is this get. For this get is for 1. Okay. Return the value. In this case is 1. And now that is the second iteration here. Yeah. 1, 1, 2. Okay. Now we have 1, 1, 2, and the other is 2, 2, 1. Now this is in this side, and this is here. We'll make the square. Okay. Okay. Now this is the most frequently. The last recently used is this. Now the next. Done and done. Now the next that is put. In this case, I am trying to put this. Means that the last element should be replaced. In this case, I know that I contain or I have 2 elements, and the size is 2. Means that I need to replace this by the last. Okay, 3, 3, 1. Yeah. Now the next is this. Is get the 2. In this case, doesn't exist. Don't do anything. Now the next that is this. Next is one put again. The lastest, no, the lastest, the, yeah, the element that appear in this side is 4, 4, and 1. Okay, done, done. Now the next that is the get. Get the number 1. In this case is this increasing 1. Now is 3. It is keeping the same order. Okay, now and continue, continue, continue. This is the idea with this algorithm. Now, get and put must be run in constant time. Constant time. Usually, where we have this kind of problems, it's very common use the pointers. You know, the linked list and this kind of structure because, and combined, for example, with the hash map, the in general the linked list help us to, for example, if we have this connection, I can modify, for example, if I know that this is the target, yeah, in the hash map, I have the keys and the node, for example, and this node have this reference. In essential is, okay, this is the target. Okay, it's here. It's exactly the same because it's with reference. Now this is connect with the next, and in this case, for example, if this is um, the last recently used, it's only reconnect this with this and this with null. Yeah. And now this is the new data structure. But let me check. Uh, if at the beginning we have this, I think that I can use a global variable named length. It's equal to, okay, and initialize um, the linked list, yeah, with a dump pointer, and it's done. It's done. Now the next that is this put. For example, for this put, I think I can create here. This is a king. This is the king. That is one. This is the value, and this is the purity. Yeah. In this case, is one. Let me check. Maybe I am confusing this. Let me check. Where's that one? But in this case, for example, what happened where I only add a new element, automatically have the most recently. Yeah, I think that is this. Let me check because maybe I am confusing this algorithm with another LRU. Sorry, translate to Spanish. Yeah. Okay, let's suppose we have an area cache capacity of 3 and we would like to perform the following operation. I put this into the cache. Second is this, as. Now I get okay. Now, this is the first operation. I introduce the A, it is the highest. Now the second is the B, and now is the new highest. Now is the C, is the new highest. Now is operation is over the key 2. Yeah, it's basically every operation. Yeah, it's not with counter, sorry. I was confused with another. No, 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 this is not necessary. It's more simple. I think that I don't remember the name of this kind of algorithm concerned to the cache, but exists another algorithm that use the weights for determining which is the cache that help us in the future based in the iterations that have the user with this cache. But well, In this case, it's very, very simple. I think that, and the final is only define this length. This only is for determine, yeah, the size. It's not. It's only that, and initialize with a dummy node or dummy pointer this list, linked list, and now every time, yeah, um, in essential is that the first is make the query. This exists here? No. Okay, create. Now create the node, save this node here. Okay, it's very, okay, yeah. And now exactly the same reference, use this for to connect with this. And now the most recently used is this. Yeah, that's it. And in this case, for example, the insert in the hash map is constant, and the insert in this is constant because we have the pointer to the last element all the time. Yeah, and now the last is this. Okay, got it. Now the next that is this. The first is check this exists here. No. Okay, create the node, the same node uh, using the reference. Now the last is connect with this, and now this is the most recently. Yeah. Now, for example, the next is one. What happened in this case? Where is a put basically is search here. If doesn't appear here, basically is return less one. Yeah. If appear here, the next, for example, is this node, this reference, automatically is this. I need disconnect. Okay. I think that I need two pointers because I need to know the previous element to this. I need two pointers. Oh, sorry. Yeah, because in this case, for example, okay, you have this reference. Do you imagine that is this? Yeah, it's exactly this, exactly the same. Now I need to disconnect this and connect with the basically is previous dot next. It's equal current dot next. Yeah. And now this is moved in this side and this is connect with this. But let me check. Mm, yeah, I think that this is my idea. Have the reference to the previous, or have a double linked list like this, or in this case, save what is the parent of the element. But I think that is more simple in this way. Yeah, in essential where I put a new element, I need to check how many elements I have. Okay, have to take the first. Okay, and I need two pointers, the left and the right. The left is because, for example, if I need to remove, yeah, for example, I have two elements. Right now, I have two elements. The size is 2. And now I am trying to put a new element that is this number 3. What happened in this case? In this case, this should be this dot next should be disconnect with this, and now instead this is with left dot next, it's equal left dot next, yeah. And and now the right is right dot next, it's equal the new node, and this is connect with this, and this is connect with this, and this is removed and remove it from here. Yeah. Okay. Okay. Now, the first is integer. I can remove it basically in size. Here is a linked list of nodes. No, with yeah, I need one um this case this have the reference to the previous. Next value. And here is pref node next. Here is dot pref equal pref. This dot next equal next. This dot val is equal val. Yeah, that's it. Enough with this. Now here is node, a linked list of nodes list, and here it's only size, it's equal capacity and list. I need a few pointers. This is def pointer left, and I need new right. Now left, but it's equal new node, and in essential this is only it's a dummy. In this case null, null, and the value less one. And now this it's equal new head list. And now list into y here's a it's only add dot add case is left, and the left all the time is the dummy. Yeah, I don't need to move. um and it's done. Now it's done. Now what is the next? The next that is the first is validate if size greater than 0 means that we have space save more elements. Yeah. In other case means that we have all slots full. Remove the node after L and add the new after right. Yeah. First is size less. And in this case, we have the space to save more. Okay, the first is check if this element exists in the map. I think that I can create a boolean, name it is exist. It's equal map.get or default. And in this case, this is the key. And the default is false. Yeah. With this, in the case that doesn't exist, this is false. In the case that exists, oh, no. Let me take the numbers. The key is greater equal 0. Okay, I think that is 1. And this greater equal 0. Then true, other case false. Yeah, basically this is an if, but with the ternary operator. Now, in this case, for example, the first time is empty the structure. I have 2 slots. 1 and 2. Okay. Now it's empty. What is the next? The next is that ask if exists. When the element exists, then we'll update the value and reference. The case that don't exist, the first say create new node. Make the new connections, save the node, the map. A little tricky, this problem. Well, in the case that exists, the first is update the values, node, current is equal map or get, because I know that exists, is the key. Now I have the node. What is the next? The next is current dot prev. Yeah. For example, if the element is this, because exists is this, I need to go to the previous, and is previous dot next, and make the connection. Now this dot previous, and make the connection. Maybe I will get a few problems with the dot next. Okay, current dot prev equal. Now, for example, do you imagine that is D, G, F. Now G is our target. Is current. G. The previous is D, and the next will be the F. Okay. Now is disconnect. The current is completely disconnect. Prev. Next, instead the current will be the next, and now next dot prev will be the prep, and now current dot prep it's equal next, that was the last, and next dot next equal current. Current next equal null. Check. Current is G. The prep, current dot prep is D. Now the next that is current dot next is F. Now I am saying that prep dot next is that D go to the next that is F. Okay, now let's connect. Now this with the F. Now next to prep it's equal to prep. That case is similar like this. Yeah, now the F is connect with D. Now current, that is this, dot prep, it's equal next. Yeah, basically, dot prep, yeah. I am saying that this. And now current dot next is equal null, but I need to reference next. Next should be here. Next dot next should be current, yeah, for connect. Okay. Next dot next equal current y. I am doing two times. And now the right of right it's equal current. Yeah, for now all the time. No, no, it's wrong. It's A, B, C, D. Sorry. Yeah, if I try to change it, this is the current is C. Previous is B. Next is F. And here I need contemplate the last. Yeah, in this case the last is the right. In prep next, the connection between this yeah is like this. Yeah, okay, now see, this is our target, previous is B, the next is F, and the last right, right, okay, that is E. Now prep, that is B, B dot next equal next, that is F. Okay, now the B is connect with the F, D, right? Sorry, is B is connect with the Now next is D prep is equal prep. Prep is B. Now D is connect with B. Okay. Now next dot next D. This is wrong. Here should be last dot next should be This basically I am saying that e dot next it's equal c. Now current dot prep it's equal last. Okay, the first is b prep dot next is equal b. This here now is here. B is connected with D. Now the next that is D. This direction is connected with B. Now next dot prep. Next is this. Next is with B. Now is last dot next. The last is this. Dot next in this moment is null, but now connect with the new element that is C. Now C dot pref is equal the last current dot next equal null. Now wrong. Here should be right. Well, right dot next. And this A, B, B is connected with D. The current dot pref, this disappear because right now is in the last. Pref dot next, yeah, exactly. And now B is connected with D. And yeah, obviously, I need return the variable, right? Return n math. If exists, I don't need to touch anything. I think it's only enough return current dot value. Sorry, it's a little noisy here. I was in mute, sorry. Um, mm, 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 mm. Okay, okay, I will execute. Legal express. Ah, where? Here. I cannot find the sign map. I forget create a hash map. Tiger, int, and truth. New. And I remember where here. Let's do this. Okay, I think that I need more time, but that it's enough for this mission. I will complete in the next streaming. But well, thanks for following this streaming in. I hope see you in the next. Bye.